Hello everyone, my name is Liu Ke. I'm from Northwestern Polytechnical University. I'm very glad to have this opportunity to attend this conference. The topic of our paper is Zero-Shot Emotion Transfer for Cross-Lingual Speech Synthesis. My presentation will include these 5 parts: introduction, proposed approach, experimental setup, experimental results, and conclusion. In the first part, I'd like to talk about the background of this paper. Human speech usually contains rich emotions, such as happy, sad, excited, disgust. We aim to synthesize speech with rich emotional content for speakers. In previous works of emotional speech synthesis, emotion transfer TTS has also significantly developed, which aims to transfer emotion from an arbitrary reference to synthetic speech for the target speaker without emotional expressions. But we want to try a more challenging scenario: zero-shot emotion transfer for cross-lingual TTS. It plays an important role in various fields, such as movie dubbing, audiobook production, and speech translation. Specifically, as shown in figure, in the intralingual scenario, we get emotional information from on-scene speech reference to synthesize emotional sentences for speakers of the same language lacking emotion. As compared to this, in the cross-lingual scenario, the speech reference comes from another language different from the target synthetic speech, and the speaker can be language 1 speaker or language 2 speaker. This task has challenges on roughly 3 fronts. Firstly, there is the foreign accent problem stemming from the diverse linguistic systems and the issue of interlingual accent and emotion in speech representations. To address this, we introduce the non-autoregressive predicting coding module and the emotion encoder to learn language-specific accent features and the language-shared emotional representations. Specifically, the NPC module aims to learn prosodic patterns across different languages based on the local dependencies of speech to address the foreign accent problem. The hierarchical emotion encoder leverages Hilbert to extract a speaker-independent representation. Moreover, the Hilbert model is trained by a large amount of unlabeled data with a strong generalization ability, which can significantly improve the performance of zero-shot emotion transfer. Now we come to the second part. I will briefly introduce the AVA system. As the shown in figure, I will follow a typical speech synthesis approach framework. Delightful TTS. Our system consists of 2 main modules: the NPC modules and the emotion encoder. The non-autoregressive predictive coding module takes the output of variance adapter as input and helps the model better capture the prosody patterns of all languages from this. The hierarchical emotional encoder takes the mere spectrum as input and extracts hierarchical emotion embedding. Neural vocoder Haifigan is adopted to reconstruct waveform from mere spectrum. To tackle accent-related issues, we introduce the NPC module into our model, which is a self-supervised method and learns the speech representation only relying on local dependencies of speech. It takes the frame sequence as input and the input passes through several layers of convolution blocks, and each layer of convolution blocks will also mask out the intermediate frames layer by layer and finally add them up as hidden features. We optimize the prediction sequence and the surface feature for all time steps by L1 loss. Through mask language modeling, the NPC module can predict the target frame without seeing itself by relying on local context information and thereby address the foreign accent problem. This idea of learning contextual embedding based on the local neighbors in the sequence has been found useful in speech representation learning. Hierarchical emotion encoder mainly consists of two parts, Hilbert and the reference encoder. Since different layers of Hilbert contain distinct information, we adopt a strategy of utilizing Hilbert representations from different layers to extract hierarchical emotional features. This approach aims to improve the performance of emotion transfer compared to relying only on a single layer. As a result, we extract shallow emotion embedding using Hilbert representations from layers 1 to 12 and deep emotion embedding using representations from layers 13 to 24. The reference encoder weights and sums the representations of Hilbert's different layers to extract emotion representations. Both shallow reference encoder and deep reference encoder follow the Meyer style encoder in meta-style speech. Finally, deep and shallow emotion representations conduct semi-supervised learning through cross-entropy loss. In the experiment, two internal couples are involved in the experiments. One Chinese couple contains 7 speakers and its total duration is 23 hours, in which 4 speakers have 6 emotions including happiness, anger, sadness, surprise, disgust, hate, and fear. 2 Thai couples contains 7 speakers and its total duration is 20 hours, where only one speaker has apparent emotional expression. In addition, we implement 2 systems for comparison, SCLNGST and M3. SCLNGST is cross-speaker emotion transfer framework with global style token as reference encoder, while the model learns speaker embeddings by SCLN blocks. M3 is a multi-speaker, multi-style, multi-language speech synthesis system and extracts style information by a fine-grained style encoder. The references for these two systems are as follows. In the fourth part, here is an introduction to the experimental results. For subjective evaluation, we conduct mean opening score (MOS) experiments to evaluate emotion similarity, speech naturalness. As shown in Table 1, the proposed method in this paper achieves the best performance, emotion similarity, and naturalness, indicating the effectiveness of hierarchical emotion modeling and its ability to generate cross-lingual speech and mitigate foreign accents. In objective evaluation, we measure character error rate and speaker consonant similarity. The proposed model achieves the higher consonant similarity and the lowest character error rate, which is consistent with subjective evaluation. However, ICLNGSD and M3 exhibit higher character error rate in speech recognition than the proposed model, indicating that both models may face challenges in preserving linguistic clarity while transferring information in Chinese and Thai languages. In the ablation study, we compare our four models' performance with three variants. First, without the NPC module, the second using only shallow level emotion representations instead of the hierarchical ones, and the third using only deep level emotion representations instead of hierarchical ones, as shown in table. Removing the NPC structure leads to a small decrease and in naturalness, indicating that the NPC module plays a critical role in addressing the foreign accent problem and improving the naturalness of synthetic speech. On the other hand, when relying on single-level emotion representations, we noticed a significant decline in expressiveness. Moreover, we find that the model without shallow emotion representations exhibits lower emotion similarities than the model without deep emotion representations. However, it demonstrates lower character error rate and higher speaker similarity. These results suggest that shallow emotion representations contribute to emotional expressiveness, while deep emotion representations contain more semantic information, benefiting natural speech and accurate pronunciations. There are some demos we can listen together. First is a Mandarin speaker. This column means target speaker.
惨呐，2个月一台也卖不出去，进货价太高。
This is reference, and this is target audio.
哎，你说这两个孩子啊，我看他们感情挺好的呀，怎么还不结婚呢？
หลานว่าเด็ก2 คนนี้ยายเห็นว่าพวกเขาสนิทกันมากเลยนะทำไมยังไม่แต่งงานกันสักที
不是，而且这人也太损了，他就泄露几页，我还能让秦燕飞改改，他把整本都泄露出去了，这是要重写啊！
ไม่สิคนนี้จะเร็วเกินไปแล้วถ้าเขาปล่อยไปแค่ไม่กี่หน้าฉันยังให้ชินเยี่ยแก้ให้ได้แต่เขาเล่นปล่อยทั้งหมดออกไปนี่มันต้องเขียนใหม่เลยนะ
Second is a Thai speaker.
ผมว่าคุณคัตเบิร์ดน่าจะสบายดีนะ
อายุฉันนะมันมีเรื่องเยอะมากเลยนะ
在我这个年纪发生了很多事情
วูดเพื่อนบ้านเธอพ่นดีเยอะเกินไปหรือไงตอนเป็นเด็กน่ะ
伍德你的邻居小时候是否喷洒了过多的草药
More demos, you can access this site. The experimental result shows that the proposed approach can effectively transfer emotion from the source to a target language, synthesizing the foreign accent-free and expressively emotional speech. For people, you can access this site. Thank you for listening.